Okay, Bev, I see a couple issues. One, we need to properly solve. So when you go to graph, you have something called the slope-intercept method or just the intercept method. The method that looks like you're trying to do is the intercept method. It's where you plug in a 0 for the x and then a 0 for the y, but you're not quite truly doing it that way. So let's clean that up first. So the first thing to do is plug in a 0 for the x and you solve for y. So I get 0 plus 4y less than or equal to 360. We treat this as if this is an equals because you're solving for a point. Well, 0 plus 4y leaves us 4y. Divide by 4. So y is 90. I'm going to do that again for x. Except this time I'm going to plug in 0 for y. So x plus 4 times 0, 360. Well, 4 times 0 is 0. X plus 0 is x. So x is 360. The points that you had was 0, 0, and 0, 90. That's what I'm saying. There's one ordered pair, there's two ordered pair. That's for the first equation. Okay? So I'm going to make a little note over here. All right, let's bring in equation 2. And that's your 2x plus y less than 300. Now I'm going to do the same thing. Plug in a 0 for the x and solve for y. Plug in a 0 for the y and solve for the x. So I plug in 0 for the x first. Well, 2 times 0 is 0. Zero plus y is y. So y is 300. Let's do it again. 2x plus 0. This time I plugged in 0 for the y. Well, 2x plus 0 is 2x. Divide by 2. So x is 150. U was kind of playing a little bit of a guessing game there from what I was looking at. It's like, yeah, no, we need to properly solve. Go through the full steps. Don't cheat. So for 2, our points is 0, 300, 150, and 0. So those are our corners, and the first thing we're going to do now is graph. So here's my graph paper. And I reset the scale since we've got such big numbers to 20s. So the first one is 0 and 90. So 20, 40, 60, 80. Halfway is 90. And that is 0, 90. I'm going to go ahead and labeling. Next one is 360 and 0. 20, 40, 60, 80, 100. 20, 40, 60, 80, 200. 20, 40, 60, 80, 300. 20, 40, 60. That is 360 and 0. Because see, to know what I need to plug through my Z means I really need to know my corners. There's my line. Now, this is where the 0, 0 does come in. I'm going to move over. I'm going to plug in 0, 0 into this equation and see if I get a true statement. If I do, that means I shade towards 0, 0. So if I plug in 0 for x and 0 for y. That's 0. 4 times 0 is 0. Well, 0 plus 0 is 0. Is 0 less than 360? The answer is yes. So that means on this graph, I'm going to shade towards the 0, 0 point. Okay? I do it real light. All right, let's bring in the 0, 300 and the 150, 0. Well, if that's 90, that makes that 100. So that's 20, 40. Here's 0, 150. And I get 0, oh, sorry, I'm graphing backwards. 0, 300. 100. That's 100. 20, 40, 60, 80, 200, 20, 40, 60, 80, 300. Right there. 150 is on the X. So there's 20, 40, 60, 80, 1, 20, 40, halfway is 150. All right. Draw my line. Okay. Again, I need to find out where do I shade. So I plug in 0, 0. It's a test point. Two times 0 is 0. 0 plus 0 is 0. Is 0 less than 300? Sure is. So that means I, again, shade towards. Now this time though, I'm not going to shade up here because it's being cut off by this line. I want to see where the two different sets of crisscrosses shading happens. And it happens here. Happens in this region. So that's where I shade. Okay? Now I have one more corner and it's right there. How do I solve for it mathematically? Well, it's a system of equations. And at this point I am going to ignore the fact that I have a less than or equals. So I'm going to trot out both equations. I have x plus 4y equals 360. And I have 2x plus y equals 300. First decision, who are we going to get rid of? We could do this by substitution, or we can do this by elimination. I tend to go with the elimination. So who are we going to eliminate, x or y? Let's go for x. Because if I multiply this by his opposite, -2, it'll eliminate the x. So -2 times x gives me a -2x. -2 by 4 gives me a -8y. And yes, I have to do him too. Gives me a -720. This, I'm not multiplying, so I'm bringing him straight over. Add down, these go away. -8 plus 1 gives me a -7. -720 plus 300 gives me a -420. Divide by -7. So y equals 60. I take that and plug it back into either one. Does not matter. So 2x plus 60 equals 300 minus 60 leaves me 2x equals 240. Divide by 2. So x equals 120. It says mathematically the point where those two lines cross was 120 and 60. So let's look. 10, 20, 40, 60, 80, 100. 20, 40, 60. Oh, I counted wrong. 20, 40, 60, 80, 120. Yes, 120 is right. Let's count up. 20, 40, 60. 60. We're on the nose. So there are my corners. My corners is 0, 90, 120, 60, and 150, 0. It's these values I plug into that Z. And if I'm reading this right, this is 2x plus 12y. And we want to maximize it. So I'm going to bring in my points. And then I'm going to move up because we no longer really need the graph. So now I'm going to plug this in. So equals 2 times 0 plus 12 times 90 equals, well, 2 times 0 is 0. 12 times 9 is 108 with another 0, so it's 1080. There's that one. Let's do the next one. Well, 2 times 120 gives me 240. Well, 6 times 12 is 72, so that'd be 720. If I add the two together, I get 960. All right, one more. That gives me 300. 12 times 0 is still 0, so 300 plus 0 is 300. So to maximize this equation, it actually occurs at 0.90 with a max value of 180. It occurs here with a max value here. All right. There's your solution to your problem you sent me. Make sure next time, though, you post it to the online math lab. You do have access to it. All right, talk to you later.